Alright, so we're going to have a look at a question from the 2020 HSC Standard 2 Maths paper. This is question 35. So this is quite a long question. This is one of the longer questions in the paper. We're told the intelligence quotient IQ scores for adults in City A are normally distributed with a mean of 108 and a standard deviation of 10. The IQ scores for adults in City B are normally distributed with a mean of 112, standard deviation of 16. Yin is an adult who lives in City A, has an IQ score of 128. What percentage of the adults in this city have an IQ score higher than Yin's? Alright, so we're going to do this by understanding or remembering what our normal distribution looks like. So he's in City A. City A, mean is 108, standard deviation is 10. So if we draw a normal distribution, we have something like this. The middle score is the mean, and then the standard deviations go up and down from the mean. So 98, 118, 128, 88, and so on. The percentages of scores in these regions are approximately known. So these are both 34%. These are both 13.5%. 13.5%. If we go up, we get 138. This is about 2.35%. This is about 0.15%. If we go down to 78, this is about 2.35%. This is about 0.15%. So these are all the approximate percentages of the population that fall into these categories. We're told Yin has an IQ score of 128. That is here. What percentage of the adults in the city have a score higher? Well, 2.35 plus 0.15, these ones, that's 2.5%. So 2.5% are higher than Yin in terms of IQ. And this is the answer to part A. Now, if we have a look at part B, we are told there are 1 million adults living in City B. Calculate the number of adults in City B that would be expected to have an IQ score lower than Yin's. Okay, so we need to find the percentage of people in City B that have an IQ score lower than Yin's. Multiply that by 1 million, and that will tell us how many roughly will have an IQ score lower than Yin's. So now we need a normal distribution. This time we're drawing it for City B. So we have a mean in the middle, 1 standard down, 1 standard up, 2 standard down, 2 standard up, 3 standard down, 3 standard up. For City B, the mean is 112, and the standard deviation is 16. So 128, add down, we get to 96, then we get to 80, then we get to 64. Up, we get to 144, and then 160. Now, percentages are all the same, right? 34, 34, 13.5, 13.5, and these are all percentages, remember. So these are known percentages associated with a normal distribution. 2.35, 2.35, and then 0.15 on each tail end. And these are just approximations, but they're pretty good approximations. The question is, what percentage of people in this city have an IQ less than 128? Well, that's everyone down from 1 standard deviation up. So that's the 50% at the bottom plus 34%. That means 84%. 84% of people in City B have IQ less than 128. So calculate the number of adults in City B that would be expected to have the IQ score lower. This is going to be 0, so the number will be 0.84 multiplied by 1 million. This is 840,000. And this is the answer. So there'll be about 840,000 adults that have an IQ less. In practice, it could be up a little bit, it could be down a little bit. This is just an approximation based on the fact that these data sets are normally distributed. Now this question has a third part, part C. Simon, an adult who lives in City A, moves to City B. The z-score corresponding to his IQ score in City A is the same as the z-score corresponding to his IQ in City B. By first forming an equation, calculate Simon's IQ score, give your answer correct to 1 decimal place. So this is a slightly complicated question. And we need to use the definition of z-scores. So z-score is equal to the score in question minus the mean, or the score in question minus the mean, which in this case will be x bar, divided by the standard deviation, which we'll write as mu. Now we know the z-score that he has in City A, z-score from City A is equal to the z-score from City B. Now we don't know what his IQ is, but we do know those two z-scores are equal. We do know the mean from City A, the mean from City B, the standard deviation from City A, and the standard deviation from City B. So the z-score for A is equal to his IQ minus the mean from A, which we were told was 108, divided by the standard deviation from A, and we were told the standard deviation for A is 10. And we know this is equal to the z-score in B, which is his IQ minus the mean for B, which was 112, divided by the standard deviation for B, which was 16. So we have this equals this. This gives us x minus 108 over 10 is equal to x minus 112 divided by 16. Multiply both sides by 10. Notice this is an equation only with x as an unknown. So 10 cancels, 10 cancels, 16 cancels, 16 cancels. 16 in front of x minus 108 is equal to 10 in front of x minus 112. We could expand these. We'll get 16x minus 16 times 108. That's 1,728. 728 is equal to 10x minus 10 times 112. That's 1120. We're going to minus 10x from both sides. 10x. We will add 1728 to both sides. 728. Cancels these, cancels these. This gives us 6x is equal to 2,848. Divide both sides by 6. And we will find that x is equal to 2848 divided by 6. That gives me, sorry, we have a plus here. This is, let me correct this. This is equal to 6x. This is a minus, so minus 1120. So 1728 minus 1120. This is 608. That's better. 608. Divide both sides by 6. This gives me x is equal to 608 divided by 6. That is 101.3 repeater. 101.3 repeater. So that's about 101.3. So give your answer correct to 1 decimal place. 101.3 is correct to 1 decimal place. And this is the answer that we're after. In terms of the marking for these questions, this is worth a lot of marks. And so you've got to be, because it's broken into a lot of parts, it's reasonably straightforward to get each of the marks, but it is worthwhile to be careful anyway. So for part A, we need 1 mark. You have to find the percentage. So pretty much demonstrate that the 2.5% somehow relates to 2 standard deviations, understand something about this curve, and then the correct statement that 2.5% or higher will get you the 2nd mark. For part B, you need to demonstrate the yin is 1 standard deviation above the mean for the new city. So identify that the 128 is the 1 standard deviation above, and then you need to correctly find the number to get the 2nd mark. For the third part, to get 1 mark, you need a correct expression for the z-scores of either one of the cities or the other. To get the second mark, you need an equation linking the two. And then to get the third mark, you need to provide the correct solution. So this will go through and then round the answer to 101.3 to 1 decimal place. So this is the marking for this question. This is how this question works. It's reasonably straightforward. You've got to be careful with your arithmetic. So you'll notice I made a mistake here where I added these two numbers. This is a very typical kind of mistake. It's a mistake you can pick up on because when you go through the rest of the question, the answer that I was getting was something like 400. 400 is obviously not an answer here, right? This is about IQ. You know from at the start of the question that the answer is going to be something like 105 or 100 because you can see from the two graphs that in order for the z-scores to be similar, they need to be just a little bit below the average, right? So and you can just tell that by looking at them, right? So you can tell that it's going to be roughly that. When you go through this, as long as you're careful with your working, you won't really run into any problems. But look for red flags if you make these, right? The mistake I made here is a clear red flag. You need to go back, check the algebra, check your working was actually correct. It's a very, very easy mistake to make, and anyone can make it. You're more likely to make it in an exam, so be very aware of these. If I make a mistake, I can fix it, right? I already have all my qualifications, but when you're in the exam, if you mess up these questions, you're just going to lose those marks, and that's something you want to try and avoid if possible.